Modernage MCQs Physics second year, unit number 16, Physics of Solids, part 4. The constant of proportionality in the relation stress proportional to strain is known as option A, coefficient of viscosity, option B, modulus of elasticity, option C, coefficient of friction, option D, gravitational constant. The key is modulus of elasticity, therefore the correct option is B. Reason: within an elastic limit of a solid body, it is found that for small deformations, stress is proportional to strain, or stress is equal to constant into strain, or stress is equal to E into strain, or E is equal to stress divided by strain. It is the definition of Oak's law. Hence, the constant of proportionality E is called modulus of elasticity. A concrete block is founded to be option A, elastic, option B, ductile, option C, brittle, option D, tough. The key is brittle. Therefore, the correct option is C. Reason: A, elastic. A concrete block is not elastic because it cannot return to its original shape after removal of deforming force. B, ductile. A concrete block is not ductile because it cannot be stretched into a thin wire or threads by deforming forces. C. Brittle. A concrete block is found to be brittle because it breaks easily by a deforming force. D. Tough. A concrete block is not tough because it cannot absorb sudden shocks of deforming force. Hence, a concrete block is brittle. A graph of a deforming force F versus extension X in the length of a wire is a straight line. The gradient of line gives option A, stress of a force, option B, strain due to force, option C, force constant, option D, shear modulus. The key is force constant. Therefore, the correct option is C. Reason: in Oak's law, F is proportional to X, or F is equal to Kx, where K is equal to F divided by X, and it is the gradient of line, is generally uh, called force constant and specially spring constant when someone is dealing with extension of spring by a deforming force. Hence, the gradient of line gives force constant or the spring constant. What is the strain energy in a rod 1 cubic meter when strain to stress ratio is 1 to 2 into 10 power 7 Newton per square meter? The option A, 10 megajoule per cubic meter, option B, 5.0 megajoule per cubic meter, option C, 2.5 megajoule per cubic meter, option D, 1.0 megajoule per cubic meter. The key is 10 megajoule per cubic meter. Therefore, the correct option is A. Reason: the strain to stress ratio is 1 to 2 into 10 power 7 Newton per meter square. Therefore, the strain is equal to 1 and the stress is equal to 2 into 10 power 7 Newton per square meter. The ratio stress to strain is equal to 2 into 10 power 7 divided by 1 Newton per square meter, or stress is equal to 2 into 10 power 7 Newton per square meter into strain. The strain energy per unit volume is U is equal to 1 by 2 into stress into strain, which is equal to 1 by 2 into 2 into 10 power 7 into strain, which is equal to 10 power 7 into strain square, because 1 by 2 is cancelled with 2 and strain into strain is strain square, or U is equal to 10 power 7 into 1 whole square because tan is equal to 1. Therefore, U is equal to 10 power 7 joule per cubic meter, which can be written as 10 megajoule per cubic meter. Hence, the strain energy in the rod is 10 megajoule per cubic meter. The electrical nature of solids is determined by the size of option A, valence band, option B, forbidden band, option C, conduction band, option D, nuclei of atoms. The key is forbidden band. Therefore, the correct option is B. Reason: a band which exists between valence and conduction band, electrons are free, is called forbidden band. The size, that is energy, of forbidden band varies solid to solid. If the size of forbidden band is EFI of insulator, EFS of semiconductor, and EFC of conductor, then EFI is greater than EFS greater than EFC. Hence, the electrical nature of a solid is determined by the size of forbidden band. Note: the valence and conduction bands overlap in conductors. Hence, the size of forbidden band is 0 in conductors. The charge carriers in semiconductors at room temperature are about option A 10 power 38 per cubic meter, option B 10 power 28 per cubic meter, option C 10 power 21 per cubic meter, option D 10 power 11 per cubic meter. The key is 10 power 11 per cubic meter. Therefore, the correct option is D. Reason: the electrons and holes are charge carriers in semiconductor. Thermal agitation of atoms at room temperature breaks covalent bonds and creates electrons-holes pair of charge carriers in semiconductors. Hence, the estimated charge carriers in conduction band in semiconductors at room temperature are about 10 power 11 per cubic meter. The valence band overlaps conduction bands in option A, ebonite, option B, gold, option C, gloss, option D, silicon. The key is gold. Therefore, the correct option is C. Reason: the ebonite and glass are insulator with large size of forbidden energy bands. EF is greater than 3 electron volts. The silicon is a semiconductor. Its size of forbidden energy band depends upon temperature. Therefore, the valence band overlaps the conduction bands in gold because it is a conductor. Hence, the valence band overlaps the conduction bands in gold. Copper is a good conductor because it contains large number of free option A neutrons, option B protons, option C electrons, option D nuclei. The key is electrons. Therefore, correct option is C. Reason: neutrons and protons exist in the nuclei. They are bound in the nuclei and oscillate in the ions of copper about their fixed position. The copper metal is a good conductor because it contains a large number of free electrons to carry large charge for flow of current. Hence, the copper contains large number of free electrons.